What is a black hole? A black hole is a cosmic body of extremely intense gravity from which even light cannot escape. Black holes usually cannot be observed directly, but they can be observed by the effects of their enormous gravitational fields on nearby matter. What is the structure of a black hole? The singularity constitutes the center of a black hole, hidden by the object's surface, the event horizon. Inside the event horizon, the escape velocity exceeds the speed of light so that not even rays of light can escape into space. How is a black hole formed? A black hole can be formed by the death of a massive star. At the end of a massive star's life, the core becomes unstable and collapses in upon itself, and the star's outer layers are blown away. The crushing weight of constituent matter falling in from all sides compresses the dying star to a point of zero volume and infinite density called the singularity. Let's discuss its details. Details of the structure of a black hole are calculated from Albert Einstein's general theory of relativity. The singularity constitutes the center of a black hole and is hidden by the object's surface, the event horizon. Inside the event horizon, the escape velocity, i.e., the velocity required for matter to escape from the gravitational field of a cosmic object, exceeds the speed of light, so that not even rays of light can escape into space. The radius of the event horizon is called the Schwarzschild radius, after the German astronomer Karl Schwarzschild, who in 1916 predicted the existence of collapsed stellar bodies that emit no radiation. The size of the Schwarzschild radius is proportional to the mass of the collapsing star. For a black hole with a mass 10 times as great as that of the Sun, the radius would be 30 kilometers, 18.6 miles. Only the most massive stars, those of more than 3 solar masses, become black holes at the end of their lives. Stars with a smaller amount of mass evolve into less compressed bodies, either white dwarfs or neutron stars. Black holes usually cannot be observed directly on account of both their small size and the fact that they emit no light. They can be observed, however, by the effects of their enormous gravitational fields on nearby matter. For example, if a black hole is a member of a binary star system, matter flowing into it from its companion becomes intensely heated and then radiates X-rays copiously before entering the event horizon of the black hole and disappearing forever. One of the component stars of the binary X-ray system, Cygnus X1, is a black hole. Discovered in 1971 in the constellation Cygnus, this binary consists of a blue supergiant and an invisible companion 14.8 times the mass of the Sun that revolve about one another in a period of 5.6 days. Some black holes apparently have nonstellar origins. Various astronomers have speculated that large volumes of interstellar gas collect and collapse into supermassive black holes at the centers of quasars and galaxies. A mass of gas falling rapidly into a black hole is estimated to give off more than 100 times as much energy as is released by the identical amount of mass through nuclear fusion. Accordingly, the collapse of millions or billions of solar masses of interstellar gas under gravitational force into a large black hole would account for the enormous energy output of quasars and certain galactic systems. Some black holes apparently have nonstellar origins. Various astronomers have speculated that large volumes of interstellar gas collect and collapse into supermassive black holes at the centers of quasars and galaxies. A mass of gas falling rapidly into a black hole is estimated to give off more than 100 times as much energy as is released by the identical amount of mass through nuclear fusion. Accordingly, the collapse of millions or billions of solar masses of interstellar gas under gravitational force into a large black hole would account for the enormous energy output of quasars and certain galactic systems. One such supermassive black hole, Sagittarius A*, exists at the center of the Milky Way galaxy. Observations of stars orbiting the position of Sagittarius A demonstrate the presence of a black hole with a mass equivalent to more than 4 million suns. For these observations, American astronomer Andrea Ghez and German astronomer Reinhard Genzel were awarded the 2020 Nobel Prize for Physics. Supermassive black holes have been detected in other galaxies as well. In 2017, the Event Horizon Telescope obtained an image of the supermassive black hole at the center of the M87 galaxy. That black hole has a mass equal to 6.5 billion suns but is only 38 billion kilometers, 24 billion miles, across. It was the first black hole to be imaged directly. The existence of even larger black holes, each with a mass equal to 10 billion suns, can be inferred from the energetic effects on gas swirling at extremely high velocities around the center of NGC 3842 and NGC 4889, galaxies near the Milky Way. The existence of another kind of nonstellar black hole was proposed by the British astrophysicist Stephen Hawking. According to Hawking's theory, numerous tiny primordial black holes, possibly with a mass equal to or less than that of an asteroid, might have been created during the Big Bang, a state of extremely high temperatures and density in which the universe originated 13.8 billion years ago. These so-called mini-black holes, like the more massive variety, lose mass over time through Hawking radiation and disappear. If certain theories of the universe that require extra dimensions are correct, the Large Hadron Collider could produce significant numbers of mini-black holes. I hope I'm able to explain the details to you. If you like my video, don't forget to subscribe my channel for further details. You can also post your options in comment section.